places just that are still indicated in the Pacific Northwest and for that matter in California. But for the most part, we've had a really good winter, and we should be thankful for that. So I just have a couple more slides. Here I thought it was worth kind of taking a look at the atmospheric flow patterns that have produced our very snowy winter in the mountains, and in particular looking at the 500 millibar geopotential height anomalies from the 1st of December through the middle of last week. You can see there were higher than normal heights southwest of Alaska, lower than normal heights over the kind of western part of Washington State in particular. The circulation around that, around the highs, it's clockwise, and around the lows, it's counterclockwise. And part of the reason it's been so wet in Oregon, Northern California, Idaho into Wyoming is that circulation around the low that's centered off the coast of the Pacific Northwest. We've the next slide kind of, and my last slide, I believe, I try to, kind of figure out what causes those kind of anomaly patterns. It turns out that we've been experiencing a weak to moderate at best La Niña in the tropical Pacific over this past winter. The sea surface temperature anomalies are portrayed in the map in the upper left, showing just temperature anomalies something like a ½ degree or so Celsius cooler than normal right at the date line in the equatorial Pacific. And so those anomalies have been on the weak to moderate side, but the response in the atmosphere, at least over the North Pacific, has been much stronger than one would anticipate with such modest as SST anomalies. And so that's something we're trying to figure out. Don't have all the answers there, but we've been the beneficiary of that. Should note that in the map in the lower right that it is starting to warm up in the far eastern tropical Pacific. This shows that shows the change in the SST anomalies over the last month or so, and I anticipate that Andrea will be talking a little bit about that, but just to kind of take away her punchlines and that sort of thing, what's happening in the tropical Pacific may mean that this winter that we've had here, not necessarily going to expect another one like it next winter. And with that, I don't know if you want, Alicia, whether you want questions at the end, but if so, I'll just turn it over to Andrea.
Yeah, I think we'll try to hold questions, or we'll answer questions at the end. If folks have questions, feel free to type them into the questions box. I don't see any yet, so it's probably a great time to hand it over to Andrea. And Andrea, I'm going to give you control here.
Okay. Thank you. Can you see my screen?
Yep, looks great.
Okay. Thanks, Nick. And actually, good timing, good segue, and we didn't even plan that. So yeah, I'm going to talk for a few minutes about the climate and the drought outlooks coming out of the Climate Prediction Center, which is part of the National Weather Service. And so as Nick said, we have been experiencing this winter a weak La Niña, and as of right now, the La Niña conditions have subsided, and we're now in ENSO neutral territory, so meaning neither La Niña or El Nino. I'm going to give a really quick summary of what I'm going to talk about, and then I'll give it at the end too, just so you kind of know, I guess, the punchline. But like I just said, ENSO neutral conditions are present right now, went into effect in February. And the sea surface temperatures in the equator are near average across the central and the eastern Pacific, and they're above average in the eastern Pacific. ENSO neutral conditions have returned to the area, and they're favored to continue through at least spring of 2017. And I'll show you what it's kind of looking like may happen after that at this point in time. We did actually have a weak La Nina event. I know there was some discussion as to whether, because it was so weak, if it would stay around long enough to be considered an event. And under the official definitions that NOAA uses right now, it is considered, it will be considered an actual episode. As you can see down here in this yellow box that I highlighted, it did sustain itself at a negative 0.5 degrees Celsius for the seasons from July, August, September through November, December, January. So Nick showed a very similar plot. Over the past months, those equatorial sea surface temperatures were near to below average across the central Pacific Ocean, so right around this spot. Hopefully you can see my arrow okay. And above average in the western Pacific, and then definitely above average in the eastern Pacific. And in the eastern Pacific, actually, some are starting to call it somewhat of a small scale or a coastal El Nino event in that area. But it's not a basin-wide event by any means. It's mostly impactful for coastal Peru and coastal Ecuador. So really not expecting global impacts from that down there. But it is something to watch and piques our interest in NOAA and I'm sure elsewhere. So looking at the latest weekly sea surface temperature departures, this area, again, that we like to use is what we call Niño 3.4. It's this box with the bolded order around it. And it's very interesting because here is our little La Nina event starting and moving its way through the year. And then if we're looking at the weekly departures, Niño 3.4 this week is about 0.3 degrees C above. So interesting, again, something we're keeping an eye on. We just look at these weeklies. They're not totally what's considered. We actually look at the monthly departures from normal more so than the weeklies, but the weeklies are interesting to look at just to see the evolution of what's going on. Okay, so looking in the heat content in the upper ocean, you can see our La Nina event, the end of that past El Nino, and moving through our La Nina event and then back up into the neutral area, but getting warmer. This particular area that I'm talking about is from about the date line over to 100 degrees west in the eastern Pacific. Okay, looking at the forecasts. So I put two forecasts up here because this official one comes out in early February, and this forecast is created by the Climate Prediction Center and then the International Research Institute. So this actually has both computer model input and forecaster input. And so what you can basically see is as we move out of winter and into spring, we really do expect things to stay in that ENSO neutral state. But as we start transitioning out of summer, here's August, September, October, July, August, September, we're starting to see some hints of favoring possible return of El Nino. And that's about a 50% probability by the September, October, November season next fall. Now, just a little bit of caution about that. We're not throwing an El Nino party yet by any means because we're entering this time of the year we call the spring barrier. And it's as we transition from winter and we move into spring, there's, I guess an easy way to look at it would be there's a lot more noise in the ocean atmosphere system. And the models really do have a challenging time resolving all of that noise. So the forecasters are less confident in the models. So again, they're not ready to throw their hat into the El Nino ring quite yet, but it is something to watch, and it's definitely something we're all going to be watching very closely. And then if you look at this bottom graph here, the models, when they're by themselves and they don't have any forecaster input into that, you know, they're also looking a little more El Nino-ish for late summer next fall. So it could be interesting, and I think it's something to stay tuned for. And this is another way of looking at the models. What I want to point out here is, this is a forecast plume, and all of our dynamical models, and the dynamical models use ocean and atmosphere equations to make their predictions. And then the statistical models are based quite a bit on going on those past observations. A lot of the dynamical models are really starting to jump on that El Nino bandwagon, while the statistical models are not. But again, like I just cautioned you with that spring barrier I talked about, something to watch, but not to write home about quite yet. So if we go right into the seasonal outlooks that the Climate Prediction Center produces, so I like the map backgrounds of these maps, but I do want to caution you about the way they are worded here. It says wetter here, and the wetter is placed in this contour that's a brighter color green. It's really not exactly what I want to say here. So we're slightly favoring wetter conditions or above normal conditions for the Pacific Northwest for the March, April, May season. It's just a slight tilt in the odds for that seasonal temperature to be above normal, or excuse me, seasonal precipitation to be above normal. It's not necessarily that we expect it to be more wet in that wetter contour area. It's just a little more confident in that area. So it's a little misleading, and I apologize for that. Hopefully that made sense what I said. But again, the bottom line is it's a slight tilt in the odds towards above normal precipitation for the season of March, April, May. And here is April, May, June. Again, just a slight tilt in the odds, but more moving towards the eastern side of Washington and northeast Oregon and into northern Idaho. And then really equal chances, or basically there's no favored outcome for much of the Pacific Northwest for precipitation for getting into the summer for that May, June, July period of time. So our forecast tools aren't giving us any confidence to say one way or the other. These forecasts are made in combination with longer term trends and soil moisture, and also when appropriate, we do throw ENSO into the mix. This forecast right here for March, April, May has just a touch of La Niña in it, but not too much. So moving on to the temperature outlooks. Unfortunately, not a lot to say about the temperatures for March, April, May, or April, May, June. Really, there's no favored outcome for the Pacific Northwest. As we move into summer, they are slightly favoring above normal temperatures for much of the Pacific Northwest. So again, just a slight tilt in the odds, the forecast is saying. And as Nick pointed out, really nice winter for you guys in the Pacific Northwest. So the drought outlook definitely reflects that. A few areas, just a few little, tiny little pocket there, but it's saying really they do expect drought to likely be removed. So the winter has definitely been good for the Pacific Northwest. And then I already talked, did my summary first, so I will pass it back to you, Alicia. Thank you.
Great, thanks, Andrea. So our next presenter, now that we've gone and done overviews of current conditions and a little snapshot here to the Climate Outlook, is going to be John Abatsabu from the University of Idaho, and he is going to give an overview of the Northwest Climate Toolbox. So John, I'm passing control to you.
All right.
Awesome.
You can see my screen here?
Yep.
Okay, great. So I'd like to give a brief update on a project that we're working on through the Climate Impacts Research Consortium called the Northwest Toolbox. And the gist of this toolbox is that it's a collaborative product between my lab at the University of Idaho and then also Bart Neeson's lab at the University of Washington. And actually, Nick showed a couple of the maps from our toolbox earlier, so there'll be a little bit of redundancy in here. In a pinch, the toolbox is designed to collate and uniform a collection of climate tools that we have developed through both funding from the NOAA CIRC project, as well as NIDIS and a couple other regional projects associated with agriculture across the Northwest. And these tools are designed to both improve approaches for disseminating regional climate information, as well as to help inform decision-making across the Northwest. And we're specifically targeting water resources and agriculture, both which sort of fit into the concept of drought and drought early warning systems. So the genesis of this is this big data challenge we have in the earth sciences. We have observations of climate that are coming from individual climate stations. We have output coming from climate models, seasonal forecast models, etc. And by some accounts, there's almost too much data. And that leaves us with a big challenge in terms of how to make the best use of this data, and also a big challenge in making this data accessible, especially trying to bridge this gap between the producers of data and the consumers of data. And what we hope to do with the Climate Toolbox is to basically better exploit the masses of data that we have in a way that can empower both researchers and decision makers. So our goal is to go from data to decisions, and that's sort of the goal of climate services. The data sets that we're working with fall along this stream or sort of a seamless stream of climate information. At least that's the way that we're presenting it. And the idea is that you can get observations, you can get weather forecasts, you can get seasonal climate forecasts and climate projections from a variety of sources. What we're doing is basically putting them all on the same common grid so that you can compare observations to weather forecasts to climate forecasts. And this is a common grid that covers actually all of the contiguous United States. We're actually adding the southern part of British Columbia in here so that we have data that covers the entire Columbia Basin. And our observations go from 1979. They're updated every day. So in a couple hours here, we'll have data that is updated through yesterday. And then we also have weather forecasts that go out for a number of days, and then those are seamed up with downscaled climate forecasts from the North American Multi-Model Ensemble project. And then we have climate projections as well. So what I'll focus on primarily here is just looking at observations and sort of the monitoring tools that we have available to us. So let me take you to the website itself. We actually have been working on redesigning the website, and so this is the landing page for the website. And there's a number of tools that we are developing, some which are available, some which are behind the scenes. And we have the ability for people to click on individual tools, but also for those people who are interested in sectoral interests. So if you're interested in agriculture, you can click on the agricultural icon there, and it'll basically gin up the tools that are pertinent to agriculture, and so on. So what I want to do is give you a quick overview of a couple of the tools. And Nick did a great job sort of showcasing, and I think he actually had this exact same figure. But what we have with we have this mapping tool, and it's pretty similar to a lot of the maps that are generated from the Climate Center ACES tools, except that there's a couple of differences. One is that these maps are dynamic, so you can go onto the site, you can drill down, zoom out, change colors. You can actually even mouse over and click on a location to gin up the actual value. And there's also some additional variables that we are providing. So beyond just temperature and precipitation, we also have ways to look at anomalies in things like potential evapotranspiration. For the Northwest, we're also adding, we have added actually ways to look at soil moisture percentiles, snow water equivalent percentiles, and then there's also some fire danger indices that you can look at as well. This is just an example for the snow water equivalent maps, and it's certainly been an interesting year in terms of snow. We've had sort of what I describe as an upside down snowpack, where we have abundant abundant snow at lower elevations, but there's still a few holdouts at higher elevations up in the northern panhandle of Idaho, into the Bitterroots in Idaho and Montana, where we're a bit behind normal, a bit below normal in terms of snowpack, and that's sort of an interesting thing to look at. And you can certainly get at that looking at the NRCS SNOTEL maps that Nick showed us earlier. But this is another way of doing that, using the snow water equivalent products that are being produced by Bart Neeson's group at the University of Washington. And then if maps aren't your cup of tea, we have a number of site-specific tools, and the idea with these tools is that you can click on any given location, basically across the continental United States, and get information specifically about climate. And this is just one sort of tool that we've developed. It's specifically targeted to looking at the phenology of certain dryland cropping systems that we have in the inland Northwest. This one is for winter wheat. And this is basically showing us a cumulative growing degree day tool. So in this case, we're looking at growing degree days for a location near Pullman. We had a relatively warm October and November, and so growing degree days were way ahead of schedule, and that's depicted by the red. The black line and the grays are showing us sort of the historical averages in the sort of the interquartile range. And then along with this tool, we actually are now integrating downscaled seasonal forecasts. So you can see where your current value is, and then the sort of the North American multi-model ensemble forecasts are sort of shown here. And the idea behind the forecast is that you can pair these up with sort of specific crop stages. So for example, using the current growing degree day accumulations along with the forecast, you can get an idea, and of course there's error associated with this, but you can get an idea of when your wheat may be reaching a certain pheno stage, so when the wheat may be heading. And that might be important for determining when you might be able to do some sort of on-the-farm management, whether it be for pests or other activities. We also have the ability to go on and actually look at interannual variability. And so this, again, you click on any given point and you can look at interannual variability for individual months. We're adding seasons, years, etc. And again, you can do these things with other sort of products that are out there. The potential advantage with this is that we're using a gridded data set, so it's fairly easy to access it. And there's more variables that you can look at as well. And clearly, we've had a cold year in Boise, Idaho, and much of the interior portions of the area. And then I want to end just highlighting that we do have a number of tools that are more oriented towards climate projections. I don't want to talk about that too much, but just highlight this one tool here. And this is an ag climate dashboard that we have. Again, you can click on any given location, and you can pull up some of the climatological statistics. This is for Wenatchee, Washington. And you can look at and you can compare historical 1981 to 2010 values for precipitation, potential evapotranspiration with future values under various time periods and various emission scenarios. So this is an interesting way of sort of rapidly bringing up agricultural relevant climate information at a given location. And I'll end there and just mention that the website that you can get to the Northwest Climate Toolbox is simply climatetoolbox.org. We are continually adding, refining tools, and this is an ongoing project. And with that, we are interested in getting feedback on how we can better meet the needs of the people across the Northwest in terms of climate information. So I'll end there and pass it back.
Awesome. Great. Thanks, John. Again, if anyone has any questions, feel free to type them into the chat window. And I'm going to take control again here. We're going to now move into a brief overview of one of our partner programs, or just key partner initiatives with the Northwest Climate Hub. So Gabrielle, can we hear you?
Yes, I'm here. Can you hear me okay?
Yeah, looks good. Sounds good.
Great. Well, I just wanted to give a really brief overview because I want to leave time for our final person coming on from Oregon State, Amy Garrett, who's going to kind of illustrate some of the work that's being done in the region. But we're still a fairly new organization. I'm representing, my name's Gabrielle Resch McNally, and I work with the USDA Climate Hubs, and we serve Washington, Oregon, Idaho, and Alaska. And really the purpose is to communicate information and help to develop tools so that managers can make decisions on working landscapes that really incorporate science-based climate change information. So we have a lot of partners throughout the region. We fund projects as well, have been involved in some of the projects that have already been presented here. And we also have a small grants program, and we're actually reviewing a bunch of really wonderful proposals right now for this year. We really hope that sort of what our work is going to do is to build more sustainable and productive forests, rangelands, and agricultural lands across private and public lands, and sort of in an effort to be better adapted to a changing climate. I have included our website here just to give you a little information. There's a lot of really great pieces. Part of what we're trying to do with the hubs is truly be a hub and collect information from our region that can be useful in tying it to lots of the great work that our partners do. You can find some regional vulnerability assessments, a lot of educational resources, news and events, and then, of course, decision support systems, thinking along tools as well as other data visualization. Next slide. So I think, you know, folks have already kind of talked about sort of what we can understand about current climate and weather events, and then some of the future changes. I just wanted to kind of talk more generally about some of the anticipated impacts to agriculture in the region to sort of set up Amy's presentation about dry farming in Western Oregon. Probably won't be brand new information for most of the people who are listening, but some of the things that we expect in our region are, you know, higher temperatures, which will certainly have impacts on phenology and yield, and changes to sort of the growing season in general. Decreased chilling hour with a real impact on fruit crops in particular, fruit tree crops. Greater severity of droughts and floods, as we've seen over the last few years. Less water availability, both in terms of soil moisture as well as water available for irrigation. And then this year, notwithstanding reductions in snowpack. And then again, looking at shifts in pests and disease. And there's a lot of great research being done. A lot we still don't understand about how these will change given a shifting climate, but it's something that we do expect to impact both yield and productivity, as well as the quality of our production here in agriculture specifically. And then some of the strategies that people are already engaged in or thinking about or doing further research on. This is, again, just a small list. Again, Amy's going to talk more about dry farming in Western Oregon, but there's also just increasing focus on soil organic carbon and soil health through sort of changes in tillage, often reducing tillage, green manure, cover crops, application of biochar, also changes in irrigation efficiency, and diversifying of cropping systems, and then kind of within that, looking at new genetics of livestock, as well as new varieties and new genetics of fruit and vegetables as well. And then thinking about shifts to our integrated pest management strategies, or just generally changes to how we manage for and when we manage for different pests. So with that, I'm just going to move it back to Alicia and Amy.
Okay, great. Amy, I'm going to give you control so you can advance your own slides. And can you hear us, Amy? I don't. Amy, are you there? We may have lost Amy here. Oh, there's your screen.
Looks like she's still muted. Oh, there we go.
Can you hear me now?
Yes.
Okay. I don't see my slides on my screen.
Oh, I thought you wanted to advance your own. I can pull them up if you'd like.
Oh yeah, that'd be great.
Sure.
Actually, if I could use my own as well. I've never done this before, but
Yep, there you go. Perfect.
Okay. Can you all see everything?
Looks great.
Okay, great. Okay, so I'm Amy Garrett with the OSU Extension Service Small Farms Program. I'm based out of the Southern Willamette Valley. I'm going to tell you a little bit about our dry farming collaborative project. So this project started, I've been in this position for about 6 years, and one of the most common questions we get is I just moved onto this piece of property and I'm trying to figure out what I can grow here. And I realized after getting that question over and over again, water, a lot of people are on land without water rights, or in 2015, a lot of the specialty crop growers were cut off early in the growing season, some as early as June. And many of the new farmers that are looking for land or leasing land have trouble finding land with unrestricted irrigation rights. So when I'm referring to dry farming, I'm talking about crop production during the dry season, like we have in the Willamette Valley. So a Mediterranean-like climate where we have these 4 months that are almost rain-free, and then we have our wet winter where we get 40+ inches of annual rainfall. So with dry farming, we're looking at strategies for utilizing that residual moisture in the soil from the rainy season rather than relying on irrigation. So this project to date has included case studies in Western Oregon and Northern California. There's one farmer I started visiting with several years ago in particular that's in his 70s and has been dry farming a variety of fruits and vegetables for the past 40 years. He started off in Northern California, and now he resides in the Southern Willamette Valley. So I would visit him monthly and document his practices. In 2015, I also visited 5 or 6 farms in Northern California that have been dry farming fruits and vegetables as well. Demonstrations, the practices that I documented from these farmers, we applied on the ground at several different OSU extension sites last year. And we had field days at each of those sites doing side-by-side tastings of dry farmed and irrigated melons and tomatoes. We started to collect some yield data. And then the newest part of the project is this participatory research with interested growers. So I'm going to be focusing on that in this presentation. Some of our funding to date, we've had little pieces of this project funded by Western SARE, our Growing Resilience Water Management Workshop Series, and then the dry farming demonstrations were funded in part by USDA NIFA, Beginning Farmer Rancher Development Program grant. So when we are looking at dry farming and how it all works, it really does start with the soil. All the growers dry farming are on sites that have soil with good water holding capacity, using a variety of practices to increase soil organic matter, cover crops, compost, etc., and have deep soils. So they're not shallow, gravelly, or sandy soils. They're 4 inches or more of soil. When they're selecting sites, one way that someone new to dry farming could select a site is look at the existing vegetation, using plants as indicators, and see where things look particularly green in August after we've had our 3 months with no rain, like here in the Willamette Valley. We also have been using soil augers to pull 5-foot soil cores to look at what things look like 5 feet down. A lot of our soil sampling is done on that top foot of soil, but in dry farming, crops are rooting much deeper. The little snippet here on the right is from the Web Soil Survey. So this is the farmer that I case studied that's in his 70s and has been doing this for a long time. This is the soil he's currently dry farming on, and you can see and under typical profile, this is a clay loam, and it's you have more clay content in that bottom, below that foot, the top foot of soil. Depth to restrictive feature, more than 80 inches or 6 feet of soil there to root into. So another thing we look at, and we're going to start looking at more this year, is the depth to the water table. So some sites that people are dry farming on have high water tables early in the season. So all these will affect how, dry farming. Soil preparation and timing are also key. Planting when and where there's moisture, so not waiting till the soil dries out to plant. So it's kind of a dance between soil temperature and soil moisture. We are spacing plants out a bit more widely, typically starting off with like double what you would in an irrigated situation. Pressing in the soil just around the seed or transplant to bring that moisture to the surface through capillary action. Another technique is pre-soaking seed so you can get germination more quickly. And surface protection. There's a lot of growers in our group experimenting with a variety of different ways of surface protection, but the one most traditionally done is dirt mulch or dust mulch, some call it, but keeping those top few inches loose. And the crops, this is a stylized illustration by Moria Peters of dark star zucchini, and we're planting early when there is moisture towards the surface, and this just shows that those roots are following that moisture down over the growing season. So these are some pictures of the crops that are being dry farmed in this project. Tomatoes, potatoes. Tomatoes are probably one of the most popular one. There is quite a following and a lot of interest in the dry farm tomatoes. Also down in the bottom right corner you can see this is Jacques Newcomb in Willow Creek, California, and that's his dry farm peach orchard. And right next to that some picture of his dry farm melons, and he's known in that area for both his dry farm peaches and melons, and we'll have people in line a half hour before markets start because the flavor, so increased or improved flavor is definitely one of the reasons dry farming is gaining momentum and interest amongst consumers as well. So our dry farming project in 2016, we had 3 demonstration sites scattered throughout Western Oregon. This little diagram at the bottom shows what one of our demonstration sites looked like here in Corvallis. We were looking at several different treatments: irrigated, low irrigation, dry farmed, and then we had a dry farmed with biochar compost, looking at several different crops and varieties there. So the Dry Farming Collaborative, there were many growers hosting trials on their lands as well. So we initiated the Dry Farming Collaborative in the spring of 2016, and we are a group of growers, extension educators, plant breeders, and agricultural professionals, all partnering to increase knowledge and awareness of dry farming management practices with a hands-on participatory approach. In 2016, there were 10 main sites throughout Western Oregon. This map is a picture from our winter growers meeting just this past December, and we had everybody involved in the project put a pin on the map to identify where they're located. So that's we are expanding a bit more each week, it feels like, but that's what 2016, what our group looked like. We have more than 180 members on our Facebook group now, and we have an email list that we're coordinating our trials with and getting our seed order together, so doing a lot of our internal communication via our email list, and then anyone interested in the project can get a good window in by joining our Facebook group. We allow public and anyone interested really to join the Facebook group. That we collected this year, I mentioned the 5-foot soil cores, collecting some yield data and doing these tastings. And learning that everybody has a different capacity and interest in collecting data. So we're trying to design this project to be inclusive and make it so that everyone's contribution can count in some way. So we're working together to figure out what that looks like. And but being inclusive is one of our guiding principles here. This is a few pictures from one of our dry farming trials at Gathering Together Farm in Philomath, Oregon. Their tomatoes, this is a farm that has plenty of water available typically, although in 2015 they did get their irrigation cut off in, I believe, September, and they do have senior water rights, so that was alarming for them. So they participated in our trial last year, and their tomatoes that went to market were a big hit. So even though they have the ability to irrigate, this year they intend to expand their dry farm tomato plot to kind of tap into this niche market. So there's a lot of different reasons people are dry farming, and not all of them are on land without water rights. Some of them are interested in this improved flavor and quality of fruit. So on the right, you can see early, mid, and late season of their dry farm plot there. And this is one of the sites where, when we were planting, the water table was just 3 feet below the soil surface. And we were planting the tomatoes about a foot deep. So they were pretty close to tapping into that water table early on. And this is just a representation of some of the data we've started to collect. And here you can see that these are both squash varieties. Stella Blue is on the left, and the Zeppelin Delicata is on the right. And we have dry farmed with biochar compost, low irrigation, and irrigated as our treatments there. This is a quick visualization just to see that the Stella Blue is a dry farm squash variety. The Zeppelin Delicata is one commonly grown by growers here, but it's not a dry farm variety. So we notice again and again that these dry farmed varieties stand out in our trials. Dark Star Zucchini is another dry farm variety. We planted this one in late May, and it started fruiting early July in 2015. This is the drought year we had here in the Willamette Valley, and it produced all the way through September without even wilting on the hot, dry days. So there's some qualities of that we're pretty intrigued by this, and we're starting to expand this part of the project and look at selecting for more varieties that are drought tolerant or conducive to this system. Also, soil productivity ratings. This is an older publication by Herb Huddleston. So this table was compiled by Andy Gallagher of Red Hill Soils, who helped us with our soil cores this past year. And we have each of our dry farming trial sites listed on the right and the different soil types along the left. And there is a native productivity rating and also a dryland productivity rating. And we're trying to come up with tools as we start to see differences across the sites, knowing that soil is going to really impact the kind of results people see. This could maybe help us in explaining some of those differences. And this is a quick look at an example of that. You can see along the right here, we have 3 different sites. This is Gathering Together Farm, North Willamette Research and Extension Center, and Oak Creek, so 3 of our dry farming sites. Gathering Together has their dryland productivity rating was 73, and their tomato yields were much smaller. So we had different varieties of tomatoes, but I just wanted to bring attention to that their dryland productivity ratings are smaller, and so is their yield. So these might be things that help facilitate our conversations and explaining differences. So for 2017, we are getting our seed requests our seed request forms out to the growers. We just sent that out on Friday. These are some of the varieties that the growers selected, and we kind of narrowed down that list with a bunch of the plant breeders. And there's a lot of genius in this group, and it's coming from growers with years of experiences and many brilliant plant breeders. So we are tapping into that knowledge and selecting things together, and we've narrowed it down to these few varieties that we'll be doing replicated trials on. Some of our next steps here, we have nearly 30 sites signed up to host dry farming trials this year. Like I said, we are emphasizing replication. Last year, everybody was just getting started, trying things out, sharing information on Facebook and at our meeting. This year, we'd like to really do focus on replication and get some more meaningful results from our trials. So we are going to be focusing on developing our dry farming page on the OSU Small Farms website to be a resource hub and make it easier to find some of these resources. We will be starting to take some of our field trial results and developing some introductory publications for those new to the project, new to dry farming, on site assessment and selection and soil preparation and planting, and doing some case studies as well. There is a lot of interest in the group, as I mentioned, on plant breeding and developing more open pollinated dry farm varieties and selecting these varieties that do well, because that is one of our most valuable tools we've noticed already. We'll also be looking at ways to streamline our data collection process and develop tools for that. And oops, sorry about that. And also potentially use this project as a template or a case study, and documenting our process, so how illustrating how others in other areas might develop participatory climate adaptation research projects. We, for those new to dry farming, we always recommend starting with a site that has deep soil and good water holding characteristics, and then starting very small and expanding on your successes. So anyone that is experimenting on their own is welcome to join our email list or our Facebook group. And there's more information on our website, and I'll be improving upon that in this coming year. And that's all I have for you.
Great, thanks, Amy. So that was our final speaker, and at this point, I don't see any other questions. So if anybody has a question, now's the time to type that into the questions box. And I think all of our speakers are still online, so you can have an opportunity to ask that of them directly. I'll take here the controls back real quick. I just want to thank all of our presenters here today. It was a really great snapshot and overview of what a DEWS entails. By having we have a wealth of resources in the Pacific Northwest. So Nick Bond with the State Climate Office from Washington, tapping into our partners at the Weather Service with Andrea and the Climate Outlook, highlighting some tools that have been developed as part of the DEWS, but through sister programs with the NOAA RISA program and CERC, and John Watzelgo at the University of Idaho, and then really capitalizing on some of our partnerships here, which is a cornerstone to the DEWS, by working with the Regional Climate Hub in the Northwest and being able to highlight what Amy's doing with Oregon State University Extension. So it was a really great overview, I think, and I see one question. Oh, perfect, Karen, for John. And it looks like her question is, for the UW drought monitoring system output that is now in the climate toolbox, snow water equivalent, etc., is that the same on both sites, or is it different on the Northwest climate toolbox in some way? John, if you're still on the line, do you want to take that?
I didn't quite get it. Something about drought monitoring?
Yes, sorry, here, let me say it again. It's from Karen Babako at the Washington State Climate Office. Basically, she's asking about the UW drought monitoring system output that's now on the climate toolbox for snow water equivalent. Is that the same on both sites, or is it different on the Northwest climate toolbox?
Okay. That's a good question. Yeah. So there is a website at the University of Washington. There's also one being run out of UCLA, and it's basically the same sort of products in that it's snow water equivalent, soil moisture, and sort of combined moisture. The products that we are providing on the Northwest Toolbox are slightly different in that they're coming from a different data source. So the data source that I talked about, this gridded meteorological data set from 79 onward, is what is being used and being run through the University of Washington and BART's group currently. And that's different from the meteorological inputs to the existing site on the UW website, and also at UCLA. So there are some subtle differences in it, that's maybe useful in looking at, if you're dealing with uncertainty in monitoring drought, there's different data sets to look at, and that might be useful in that regard.
Great. Okay, I don't see any other questions. So thank you all. Thanks especially again to the speakers. Thank you for attending. The resources will be available on drought.gov. You'll see the link for the next webinar on your screen. And as a personal note, this is my last week with NIDIS, so I really look forward to see what comes out of this group in the future. And it's been an absolute pleasure to get this Pacific Northwest DEWS up and running, and definitely one of the highlights of my job or time in this position. So thanks to all of you for your enthusiasm, and I think that's it. So thanks again.